The place where we see the most advanced combinations of AI with model-based design is definitely in the automotive industry. At the companies that we work with, we encounter many tools. This is also a challenge that the managers and the team leads have to deal with.
Once you give them an implementation plan, they kind of know how they would do it themselves, or are you still a point of contact when something potentially could go wrong?
Once we execute the implementation plan and we finish sort of like the pilot project, ideally, they should be ready to continue the next project on their own. I have to get my system to at least 80% accurate, and the only possibility I had was with AI. If we speak about this combination of artificial intelligence with model-based design, the three primarily cases that we see are virtual sensor modeling, reduced order modeling, and reinforcement learning. All those three use cases are bringing really something additional to the development of the product. Complication then it's about leveling up the skills of those teams and really making sure that you enable them and empower them with the right techniques and tools so that they can easily collaborate together, because they're definitely talking different languages. Like a data scientist will talk a different language than an electronic engineer or mechanical engineer. And so managers and team leads have to find a way to make that collaboration smooth, and that eventually the development of the whole product, including the engineering part and the artificial intelligence part, it's augmenting the value of their product. We call on-ramp courses. This is also something that a lot of people are not familiar with. They are for free. When you are talking about developing a product and putting software into it, you have to be aware of those software development practices.
Ladies and gentlemen, today we'll talk about a very special topic, AI for engineering leaders based on model-based design. So the question is, what does that mean? But before we jump into the nitty-gritty, Paola, welcome to the office, by the way.
Thank you.
Really nice. How did we get to know each other in the first place?
Yeah, first of all, thanks a lot for the opportunity. It's really great to be able to conduct this podcast live in person, finally. Mm-hmm. And I think it was really great to that we met each other through our colleagues. And that, we understood that we live in the same city. So that was really great to have the opportunity to be here together in the city of Eindhoven.
Yeah, I learned it quite late that there's actually a MathWorks office, literally 10 minutes, 15 minutes, if there's no traffic, by the way, we have to say. So we'll talk about maybe your background a little bit, like what are you doing at MathWorks and what is your background, your educational background?
Yeah, absolutely. So I'm an engineer. I am educated in electronic engineering, and I specialized in signal processing systems. I studied in Italy, at the Polytechnic of Turin. I did my master's in Switzerland at IBM, and I specialized there on energy management systems and sensor technologies. And I work with algorithms and models, essentially, trying to build a data processing chain that would be able to monitor the health of structural buildings through sensor data. And eventually, I ended up in the Netherlands and at the University of Eindhoven, and I spent there 5 years doing research on signal processing systems that could be augmented or extended with AI, and again for monitoring systems for energy consumption specifically.
Have you been using MATLAB your whole life, basically, now?
Yes.
Okay, how many years?
Oh, I lost the count. Many years.
You're very familiar with the MATLAB product and also the MathWorks portfolio. Really cool. So, okay, let's delve into it. Like model-based design, what does it mean from the first principles, and how can it help engineers facilitate their work?
Yeah, so I can answer that from my own personal case. So in my career, models facilitated the way how I thought about putting together different components of my system. And I could have done that also with algorithms, but it was somehow more cumbersome to do so by using a model that I could easily represent in an environment like Simulink. It facilitated my life, and I could think of what we call multi-rate systems, so systems that run at different frequencies, and also multi-domain systems that not only incorporated signal processing, but other components like mechanics, controls. And then I could have a whole view of the system, and I was able to simulate it and to eventually, once the model was really good, and really like the performance was really good, I could eventually put it on a sensor node, meaning deploying it, for example, into an FPGA or a microprocessor. So that I could have not done it only with algorithms. And that's the power of like doing model-based design or model-based development.
Is there some, obviously you talked about the advantages of it, but is there also some downsides of doing model-based design?
Not that I'm aware of.
Not that you're, okay, cool. Okay. You walked us a little bit through the process of how you would actually go about doing model-based design. Are you using MATLAB for that, Simulink, or is there other products from your portfolio?
MATLAB, Simulink, and many other products. Yeah, in my own case, it was mainly signal processing. But in general, I see a lot of mechanical components, fluids, electronic components. So you can really think of that modeling environment as a place where you can do very low level model, and being able to combine those domains allows you to simply have full simulation of the system.
I see. What is the difference? Maybe just like out of the box question. What is the difference between an engineer simulating using CFD or FEA versus using the model-based approach?
So I think in the model-based approach, you have the ability to do system level simulation and testing, and eventually putting it into a product. So you can go to the stages of development and operations and connect your hardware, for example, to the computer that you are using to model and to test. And then have that model as a single through to the whole process, and take that model and deploy it into the hardware while still connected to the computer, and do some further testing like processor in the loop or hardware in the loop, and then be very close to what the real system would look like without spending money on the hardware.
I see.
And so I think that's really powerful when you are talking to our customers at the MathWorks that are really building products that go into the market, that are being part of automotive applications, for example.
So you're basically building a digital twin, and based on the results of that digital twin, you basically see how it would perform in real life, and then make decisions based on that.
Say that these days some of those models are called also digital twins.
It's kind of a buzzword. I didn't want to mention it,
just
but
like AI.
Yeah. Exactly. Can you mention some of the use cases, maybe, of course, if you can talk about them, how people use it in the industrial world?
Yeah, absolutely. So if we start talking about the combination of the AI technologies with a model-based design, maybe some of those use cases are not yet that evident in the market because they have to go through a lot of testing and regulation and until they are ready to go in the market. The place where we see the most advanced combinations of AI with model-based design is definitely in the automotive industry. And these special automated driving features, like for pedestrian detection, where the car has to put together all the controls and the logic and make a decision based on a video or a picture of a pedestrian crossing by. I think that's one of the most common cases that we see that is being really truly tested as we speak.
Mm-hmm. I think there's a lot to unwrap, especially for people or end users, how they would use a MathWorks product to actually make this happen. But again, we want to focus more on the decision maker level.
Correct.
So is it easy for them to understand the concept of model-based design or systems, how you would build them inside of MATLAB or Simulink? Or is there some resistance from the C-level? What would you say? What's your experience?
I was trying to put together some notes while I was preparing for our conversation today, because we have been definitely talking about this topic for quite some years now. And I'm recalling some of the challenges that those managers mentioned when we talk about working together on pilot projects. And some of those challenges have to do with multidisciplinary things. Because typically, like I expressed, electronic engineer, you encounter domain experts like mechanical engineers, just like you are, that are trying to combine this power of artificial intelligence, and you encounter then this issue of having different skills in your team. or maybe it's not an issue, it's an advantage, but then the complication then is about leveling up the skills of those teams and really making sure that you enable them and empower them with the right techniques and tools so that they can easily collaborate together, because they're definitely talking different languages. Like a data scientist will talk a different language than an electronic engineer, a mechanical engineer. And so they have to find, managers and team leads have to find a way to make that collaboration smooth, and that eventually the development of the whole product, including the engineering part and the artificial intelligence part, it's augmenting the value of their product.
Yeah, it sounds more like that you provide the tools, but also you kind of also consult businesses of how they should adopt this technology.
Yeah, absolutely. And maybe I kind of speak a bit more about my life of the MathWorks at this point. I am a manager of an application engineering team, and we are here in Eindhoven. For those of you in the audience who don't know it, we have many field offices like this one, where we are the first point of contact to those engineers in the field who are challenged developing this type of systems. And what we try to do is really become an extended part of their teams by trying to understand better what the requirements of the whole system are, and trying to map it into not only software, but also processes. So we do work with what we call implementation plans, where we try to structure what the project might look like, and we divide it in phases of implementation, developing, testing, until it becomes an actual product. And these projects might take years. And of course, like I said, we are the first point of contact, but actually behind us, there is a whole team of experts at the MathWorks worldwide, from training department, from consulting department, technical support, development, you name it. And so it becomes really like an extended part of the company that decides to partner with us in this type of project.
Okay. And then once you give them an implementation plan, they kind of know how they would do it themselves, or are you still a point of contact when something potentially could go wrong?
Very good question. So what we like to do is definitely transfer the knowledge. And while we are doing this through consulting services and application engineering, we do our best to transfer our experience and expertise on the area, but they definitely have to bring their domain expertise into the picture. And once we execute the implementation plan and we finish sort of like the pilot project, ideally they should be ready to continue the next project on their own. But we always leave the door open, because this is a technology that is changing very quickly.
Yeah.
And so in a month or two, they might be reaching back to us asking for maybe new implementations or new AI models that we might be supporting in the tool. So the collaboration continues. However, the domain experts have to do the work.
I see. I'm not super familiar with it like you are, but it seems like we had a discussion with Jan and Heather about like Python versus MATLAB, which I think got a lot of like, it was a heated debate for sure. It feels like when people use open source, they wouldn't have the same level of service that you would get from MathWorks, for example. So you have the upskilling bit, which I think is pretty straightforward. Like me as a student, you go into MathWorks, you log in, you have all the material that you need to upskill yourself. How can we, like, for example, that a manager watches our podcast, what else could you give them or advise them to do if they want to take the step, but maybe they're not sure if they should come to MathWorks?
Absolutely. So I will always say first, try to talk to one of us that can really give you a sneak preview of everything that is there to explore, because it's definitely a huge amount of, let's say, materials. And not only from the MathWorks, but from other software vendors and other tools, like you mentioned, Python as well. Definitely at the companies that we work with, we encounter many tools. This is also a challenge that the managers and the team leads have to deal with. Once the teams start working together, every single individual and every team are relying on different tools. So integration becomes really, really important. And we always like to encourage engineers and scientists to really use the tools that are better for the work that they do, that they can really be efficient. So we don't like to enforce any kind of pattern or a specific feature, but we like to more talk about interoperability and the possibilities that they have to have a common understanding of what they are trying to do while working on their own environment. And by enabling that interoperability, I think the life of the managers also becomes easier, and their job becomes really about enabling the teams to do faster development.
That makes sense. You talked about the implementation plan in like 1 or 2 sentences. It sounds like it's very quick, but how long does it usually take to go from a contacting you, POC, and then building that implementation plan from beginning to the end?
Oh, it depends. Depends on how clear the requirements are, for example. So if the requirements are really clear, then we can scope the implementation plan in a matter of a couple of days. If it involves multiple teams and multiple phases like development, testing, and deployment into some kind of embedded hardware, then this might take months until you get really the requirements clear for the whole implementation. And so, yeah, it really depends on the complexity. But scoping it, I will say a couple of days.
You also mentioned the term AI, right? How does it fall into this model-based design, I would call it pattern or system?
Yeah, good question. So maybe also an anecdote from my personal experience. I started doing signal processing and trying to see how I could improve the things I was doing with sensor data to make, for example, detection of objects better. That's a very common case. I was using filters in signal processing that will allow me to clean, for example, the data that was coming up from the sensors. Then you try to group data from different types of sensors, and you try to come up with a good decision based on all those sources. And so a good decision could be like, okay, I see that a person is walking by the corridor, I turn on the lights, right? Something super simple. However, at some point, the amount of data that you have to handle, the different types of sensors becomes really difficult to manage just with signal processing. And you start feeling the need for different methods that could help you do that in a potentially better way. So with my signal processing background, I was achieving systems that were accurate up to maybe 60%. In the research world, to be able to publish a paper with the type of accuracy about more than 10 years ago, it was quite difficult. So I have to get my system to at least 80% accurate. And the only possibility I had was with AI. So we started exploring back then some really simple but still powerful models like KNN models. And we started trying to understand how to cluster the data and how to manage it better. And that already helped to improve the accuracy up to 80%. So we could start publishing our work. And so I see personally the AI technologies more really helping and improving the performance sometimes of those models. But if we speak about this combination of artificial intelligence with model-based design, the 3 primarily cases that we see are virtual sensor modeling. The second one is reduced order modeling. And the third one that we see most commonly happening is reinforcement learning. And I believe you will have your dedicated podcasts and sessions about these topics. But maybe what would be really interesting to mention for team leads and project owners working in this type of challenging projects is that all those 3 use cases are bringing really something additional to the development of the product. So for the first one, virtual sensor modeling, just as the word says, is enabling the individual engineer or scientist to have a virtual representation of a sensor that might be maybe too expensive to acquire and as a hardware, or maybe just really difficult to access. And without data, of course, you cannot really implement any kind of AI model. And therefore, having this virtual sensor representation of the actual sensor at a very high level, maybe with some statistical modeling, but also the very low level, down to the components of the sensor, where you can really model impairments of the sensor, noise environment, etc., gives you a huge advantage to basically for free collect a lot of data. So this will be the first use case, and we see it happening with our customers. So we have actually projects ongoing on this area. The second one I wanted to highlight was reduce order modeling. And it's again, like the word explains it, reducing somehow the complexity of your model without sacrificing on the accuracy of what you are trying to model. Gives you the advantage then to accelerate your simulations because the model is less complex. And some AI might also be involved on that type of use case of reduced order modeling. And the third one I very briefly mentioned was reinforcement learning, where you are also thinking of designing systems with more like data-driven type of orientation. And that allows you to explore more the design space, all the options that you could have. And the three use cases are really enabling the engineering community and the scientific community to really focus more on those design options and focus on their domain expertise while not worrying too much about how to implement AI and how to accelerate the training of models. And so I think that for the teams in general that are thinking to combine artificial intelligence with model-based design definitely opens the door to explore more projects on this area.
Yeah, that makes sense. Very well explained, Paola. I like that. I'm wondering, you mentioned data science earlier, like the different departments, how to communicate. I'm wondering, why don't companies decide to build the knowledge in-house? So basically they buy your knowledge, but they keep coming back to you. Like, why wouldn't it make sense to build it in-house with their own data science team?
Yeah, that's also happening. Very interesting point. It's taking a bit of time because, of course, when I was doing my engineering studies and my research, those careers on data science did not exist actually. So at TU Eindhoven, when I was doing my research, one of the first departments or faculties who started really with that program was the computer science and mathematics department. If that career would have been there, I think I would have been going into that direction. So having the people trained on that from the university side it took some time. And now that we have more and more graduates coming out of the universities with this type of a specialization, we see it also at the customers. They are also building their own departments of data scientists. However, what remains really difficult is that those are, again, really specialized on statistics, on mathematics, on computer science. They do not have the knowledge of certain types of machines or the automotive industry. And so that knowledge has to have some kind of level up or common understanding or upskill, as we call it, in the company. So while you are engaging in this type of project, there is this step of really training them in having a common language. And we do offer for that also our training curriculums that are specialized also on AI using MathWorks tools. We could also do some kind of additional or pre-work before you engage into such a training course, which can take a couple of days in what we call on-ramp courses. This is also something that a lot of people are not familiar with. And it takes you about 2 hours to complete one of these courses. And these are pretty easy accessible. They are for free. You find them in our website, and you have like a variety of those courses, not only specializing on AI, but also like on physical modeling, on how to do state machines. And then with hands-on exercises on your own, you can actually take a sneak preview and get a feeling for how the tool works and what does it mean to, for the first time, build a pretty simple AI model. In a matter of 2 hours, you can do that. And so if managers and team leads are really concerned or are really looking for ways how to very quickly get it started, I will say, yeah, this is a pretty accessible and easy way to do it. And of course, reaching to MathWorks, it's the best way. So picking up the phone and reaching out to us, we can elaborate more on the possibilities.
Yeah. So someone would be able to take the course even though they don't have any prior knowledge about a specific topic, which I really like because it's actually the practical knowledge that you need to actually get started. Because I feel a lot of people, especially when they want to get into the industry or like they're looking for a new job, they go to Coursera, for example. They take 10 AI courses, but what is the actual practical implication of these algorithms? Absolutely. And this is where MathWorks comes in, in the upskilling bit of it. Absolutely. I want to talk more about the challenges, also the things that you have learned on a daily basis when working with customers that might not be that obvious. Paola, can you talk about that?
Absolutely. So by talking to customers in the daily basis and in this role of application engineering, we find multiple challenges along the process of designing, developing, and prototyping, and eventually putting something into production. So in each of those phases, managers have expressed different types of challenges. I like to start with one that is the overall challenge I mentioned before about integration. So how do you make sure that once you put together artificial intelligence models with a model-based design solution, how do you make sure that you connect them and everything still works? Yeah. And like I said, many tools are in play here. And so the ability to have an environment where you can easily test your whole system while thinking of complying to regulations, for example, which is becoming really critical for AI, especially for automotive systems, this gives a huge advantage. And so in the day-to-day work that we do with customers, we try to exactly elaborate and paint the big picture of what it could look like once you have everything integrated in a single environment. The second challenge that I see more going into the specific phases of the product development, I believe, is the infrastructure that companies are actually providing to the teams to be able to train AI models and to explore what the benefits of AI are. And you, of course, or we recommend in the day-to-day basis that they will leverage more the power of artificial intelligence if they would have access to hardware and high-performance computing clusters, for example. And what we do at the MathWorks is then try to provide an easy way for those scientists and engineers who are domain experts to leverage those resources without having to worry about writing algorithms and interfaces to connect. And so I like to mention low-code workflows and apps like graphical user interfaces that can help you along the process. So we have Experiment Manager. It's one of the coolest ones I've tried. It allows you to do experiments in a very professional way. You can create templates that you can easily duplicate for many different types of experiments, not only AI, by the way. Once you have your experiment set up, it's a matter of clicking in a button to parallelize the amount of experiments that you want to run. And this for AI might mean having to run a model with different hyperparameter tuning conditions, having to run a model with different types of data sets. It's a huge gain that you get from being able to parallelize all that work. And the more hardware resources, of course, you have available, the faster you get your results. And if you don't have to worry about waiting and wasting time and while you wait for the results to come up, you can really focus on what kind of AI models I should better use, or even augmenting the design exploration. So many more models you can try it and see which one will be more beneficial for the type of application that you are developing. That was the second challenge. And the third one I wanted to mention, it's of course when you are ready with your AI model, you reach like very decent implementation, a model that performs above 90% accurate. And let's say you reach also the goal of integrating it with the rest of the system. That can be a mechanical system or some kind of a state machine, decision logic systems, etc. That integration is done. You want to make a product out of it. And we see that deployment phase going into an embedded system or into some kind of enterprise server where you can think of when we are checking for the weather, for example, how the weather looks like. All of those analytics are AI models running somewhere in a cloud-based environment. And it can be a cloud environment that you set up on-prem or your company, or it could be a public cloud environment. So what do you need to do as a team and as a manager to basically facilitate that a lot of the work that you did doesn't have to be replicated just to be able to put it in those systems, or doesn't have to be rewritten somehow. Their MathWorks dedicates a huge amount of development to make a really high quality solutions to make it possible for those teams to deploy those algorithms in an easy way. And the algorithm or the model contains everything already. So you don't have to worry about putting different pieces of codes and algorithms together. You simply have to worry about the constraints of the embedded system, for example, and what do I need to do to my complete model to make it fit there. So do I need to quantize? Do I need to prune my model? Do I need to make some choices to convert, for example, from a floating point into a fixed point so that I can really fit it there? And once those constraints are taken into consideration, again, I don't want to make it super simple, but I try it out as well. And really with the push of a button, you get the whole implementation down into a hardware, an embedded system. And that really, again, gives a lot of confidence to the managers or product owners who are really worried about testing those systems in production, because you can really have an easy path with MathWorks to get there.
Yeah. You mentioned some of the challenges that might not be super obvious to some of these managers. I was also wondering, for these reasons, for example, they reach out to MathWorks, but are there some challenges that decision makers might not be aware of that you then teach them, actually make them aware that this is actually a challenge that you guys need to solve first before we can actually jump in?
It's a really nice question. It's something that we lately are, I think, experiencing more and more. I will say the team collaboration, it's the one that strikes them most. Because I think as engineers, we all typically tend to think more down to features and tools and do not think too much the big picture. But once we start collecting all of those challenges, it becomes really evident that the team collaboration has to improve. And we have to enable that as team leads and managers. And we have to facilitate the environment where they can really collaborate in an easier way.
How do you facilitate that?
So,
it sounds easy, but I think it's very complex.
It is very complex. We do have different approaches to that. One technical approach is that we talk about software development practices. So this is a competence or a skill that it's really trained when you study software engineering, for example. Mm-hmm. So mechanical engineers, electronic engineers like us, I don't know if data scientists per se, no, I think a lot of us are not trained on this. So when you are talking about developing a product and putting software into it, you have to be aware of those software development practices and following this kind of DevOps methods, development operations. So designing, building, testing your software, being able to release a piece of software and being able to operationalize it and monitor what's the status of the whole thing and providing feedback back to development. This is something that in practice we like to bring to the teams. And that we do it in several formats. We do it hands-on, for example, with exercises. We do it with hackathons. We do it with really team exercises. Really in practice, like you mentioned before, I'm also a big fan of putting things in practice so that they can, with eventually their own project, exercise how it will be to work together, how it will be to do source control and to do testing together and pushing changes of your software and somehow being able to monitor that everything is still in good status. So that's let's say my technical approach to it. But looking a little bit higher into the managers and team leads perspective, they also like to partner with us to do what we call assessments. And those assessments can be about how the team works, about the process of developing a software. And we do that through consulting, of course, and it's providing really benefits and advantages into understanding where the gaps are. And if there are gaps on certain ways of working or also in knowledge of the tools or knowledge of the technology. And then, we might provide different solutions, maybe not for everything, but at least it gives some kind of report to the managers to understand better, what needs to be done.
Mm-hmm. Excellent. I'm not sure. I think we pretty much went through everything we wanted to talk about, unless you have some things that's again relevant for the managers listening to this episode.
I think I will say I didn't mention specific names of reference cases that we have at the beginning, but I think through the conversations I was really talking from the experience of my team working with customers. I like to encourage the audience to really reach out to us if you want to know more. In our website, there are publicly available use cases that can really prove how we are engaging with teams and managers in the challenge of combining AI with model-based design. And the two use cases that are really close to my heart are NXP and ASML, of course, because they are here in the city of Eindhoven. But especially the case of NXP, I was personally involved in that one. And we had a really clever engineer here who wanted to do exactly what I was mentioning before, trying to augment the capabilities that he was exploring with signal processing with AI, and then have some kind of advantage for the product that NXP is trying to develop. And he successfully achieved that, and he did it all the way with the MathWorks capabilities and with our support. And he implemented a super cool application where he's trying to look at data from ADC converters, analog to digital converters, and trying to see how he can use that data to come up with a better product. And he used a very simple, actually, artificial intelligence technique. Again, the most simple ones very often are the most powerful ones, called the feed-forward network. And he used his data, he trained the AI model, and then eventually he thought about the implementation constraints to put it in, for example, an FPGA system that he can then really prove to the upper levels of management that this could be of tremendous value for the NXP products. So I really like to encourage everyone to read through the available stories. And if you are curious, always reach out to us.
Interesting. I think we should also mention that because I saw your profile on LinkedIn, you are still hiring for some positions. Maybe you also want to mention that.
Yes, so we are constantly looking to expand, of course, our teams of engineers and scientists, and specifically here in Eindhoven, we have an open position. And currently, this is very critical for the deployment phase of the products that we are discussing today. So yeah, feel free to check out my LinkedIn profile and reach out directly to me if you want to know more about it.
Excellent, Paola. Thank you so much. I don't think we missed anything. In case we missed anything, we'll put relevant links in the description of the podcast and blog posts, that sort of stuff, but also your LinkedIn profile.
Absolutely.
With that, thank you so much, Paola. It was
Thank
really
you,
a pleasure. I might come over to the MathWorks office at some point
Absolutely.
in the near future. Then we can have a coffee together.
Absolutely. Happy to have you.
Thank you so much.
Thank you.